Torque, we use in our daily lives. But exactly what is torque? It's a measure of how effectively a force causes rotation, which is force times your lever arm. What is your lever arm, you might ask? It is your distance from your point of rotation all the way to the force applied. Your formula would look like this. Torque times F perpendicular times radius. Radius, you might ask, why not lever arm? Because necessarily your lever arm is your radius. You start from your point of rotation, which is your bolt, and you apply your force, and it goes in a complete 360 circle, keeping this as your center of rotation and making this where your force is. The distance, making your lever arm, which is your radius. Now, why is the force perpendicular? Let's use this door for example. Let's keep it open for now. Now let's say you wanted to close it. So I grab my doorknob and I start pulling. Why is it not rotating? I mean, I am applying a force, aren't I? But I'm not applying it in the right direction. Now, if I wanted to close it the most effective way, I would want to push perpendicular from my point of rotation, which is my hinges. So I push perpendicular, the door closes with ease. Now, let's see if I do it at an angle instead of perpendicular to the hinges. So I pull 45 degrees, not as effective. I use too much energy. I'm a lazy person. I don't want to use that much work in my life. So, if I wanted the most effective way, I would pull perpendicular all the way from my hinges. Now, lever arm. How does that deal with torque? Have you ever fought with your sisters and or brothers trying to open a door while the other is trying to close it on you? Well, have you ever pushed from the middle? You may not notice much of a difference, but it's a big difference. Now, let's keep the door all the way open. Now, from my point of rotation, I want to apply a force from here. See how long that took? Now, if it was all the way open, and I pushed all the way over here with a force perpendicular, the door swiftly closes with ease. That is because if you were to increase your force perpendicular, your torque would be increasing. And if you were to increase your lever arm, then your torque would be increasing. So if you're ever stuck in a fight between you, your brother, sister, mother, father, whatever, the trick is push as far away from the hinges as possible and make sure your force is as perpendicular as you can possibly make it. And that is torque. Now torque in math form, how does that look like? You have your force perpendicular times your radius equals torque. So if you broke it down to units, you would have kg times meters over second squared times meters. And wouldn't that give you kg times meter squared per second squared? Not necessarily. That we will work on another day. Now, what's your other unit for force? You know that all that nonsense combined into one will equal your Newton. Then radius, you can't really change it, so it'll stay meters. So then what will that give you? Newtons times meters? But why does it look like that? Well, I have no history on physics, but all I could tell you is that these are your final units, and that is torque in math.